In this section, we're going to look at 12-1, and we're going to take a look at special limits. And so introducing these special limits, there's 4 of them. And later on in this class, we're going to learn a special theorem, L'Hopital's rule. And not a theorem, but it's just a rule that helps us. And it helps us with limits. But for now, there are certain limits that we need to be able to evaluate, and there's nothing to help us. And so we just have to memorize them, take a look at its pattern, and then be able to use it from there. And so here are the 4. Go ahead and write these down, memorize them. They need to be memorized. The first is the limit as x goes to infinity of some constant over x to the n power, where n is a positive integer and c can't be 0. It's going to equal 0. And this kind of goes back to that previous lesson where we said when the denominator has the larger degree, then we know that it's going to go to 0. The second is when you have the limit as x goes to infinity of 1 plus 1 over x to the x, that equals e. Look online for a proof on that. It's actually quite interesting, but I'm not going to spend the time going over that today. The limit as x goes to 0 of sine of a over a, that equals 1. And the limit as x goes to 0 of cosine of a minus 1 over a, that equals 0. So this first one here, it says evaluate the limit. So as x goes to infinity, we can essentially break this limit up, plus the limit as x goes to infinity of 1 over x squared, plus the limit as x goes to infinity of negative 3 over x to the 4th. Now I could bring that negative out there as well. And so using this pattern here, this is just going to be 1 plus this is going to be 0 plus this is going to be 0. And so I get 1. Now on this next one, because I have this negative power, that can be flipped, so I get 1 over x squared plus 3x to the 7th. Now according to this definition here, this is 0, but if I plug in infinity, that's going to go on to infinity, and so my limit will go on to infinity. For this one here, the sine of 4x over x, we're going to use this pattern here. Now the issue is whatever a is, it has to be the same here on the bottom. So technically my a is 4x. So for me to get a 4x, I need to multiply top and bottom by 4. And so now I can rewrite this limit as 4 times the sine of 4x over 4x. And so now according to that limit definition, that's just going to be 1, and this is the limit as x goes to 0, and so that's all going to go to 1, and so I get 4 times 1, which is 4. This next one, we're going to be using this pattern here, and so this is going to be 3 times the limit as x goes to infinity of 1 plus 1 over x to the x, plus the limit as x goes to infinity of 2 cosine of pi over x. So this right here, according to this definition, that just equals e. So I get 3 times e plus, now as x gets really, really small, because it's going to infinity, so as x is getting really, really big, that number is getting really, really small. And so eventually this is just going to get, or this value right here is just going to be 0. So this will be 2 times the cosine of 0, and then cosine of 0 is 1, so that'll be 2 times 1, so it'll be plus 2. So to conclude this lesson, these are those 4 special limits that we need to memorize, and back in the lesson we used them and worked with them. We have to memorize them. So just make sure that you're putting them on flashcards or whatever strategy that you need to use to be able to memorize this, because you need to know them. This does conclude our lesson. If you have any other questions, please leave them in the comments.